we haven't really talked about three-dimensional water in great detail. We've alluded to it, but we haven't really talked about it much in the class. So, because of that, and as a result of that, and also because of the result I'm slightly brain damaged today, I've decided we're going to do an in-class quiz. Okay? Same type of setup as normal. Okay? I'd like you to do it in groups of 2 or 3. I'd like you to do this closed book, closed computer. The reason why I want you to close it is I want you guys to talk about it and sort of figure it out on your own. The grading will still be the same. If you turn it in, you get full points. If you don't turn it in, you do not get full points. So I don't really care if they're right or wrong. I just want you guys to sort of have a discussion because I think you'll be more likely to remember it if you sort of discuss it through. So get in groups of 2 or 3, and I want you to make 4 of these, one for each season. Winter, spring, summer, fall. This is off our coast in the open ocean, right? Off the continental shelf or so. And I want you to draw me the temperature profile for each one of these seasons. What you think will be the temperature profile. Think about the type of weather we get here in each of the seasons. Think about the wind, think about the heat, think about the sun. Okay? And then do your best to try to figure out what they're going to be, and then describe them very basically. Sentence at most per profile, what goes on from winter, spring, summer, fall. We clear? Okay, please include your number and your name together. Yep.
So wind would lower you guys?
Yeah, no, go ahead. Let's move.
Temperature?
You want to come sit there?
Yeah, so good. The magnitude of but does if the sun, let's say, it's twice more sunlight, will that affect the strength of the mixed layer?
Majid.
What will happen is, okay, the sun literally only heats up the top layer molecule.
Right on.
All it does. But the top energy from the molecules will slowly influence the molecules below it. But it will exponentially decrease because energy will be lost before it heat friction.
So what do you think for winter?
So it will only so what happens is you'll get
so I think there's going to be probably winter that you got more storm
those
events,
will eventually
a little bit more
become
mixing,
long static.
so the temperature will be more similar
Resulting in this
all around.
shallower,
Okay.
so smaller, less deep,
So more
farther out. Okay, does that make sense? It'll start sneaking out. Sort of
Because
farther.
because it's like surface water
Okay.
going down.
So we were saying that since it's winter, there's going to be a lot of water disturbance. The temperature's going to be
We're
pretty
taking 114. Sorry.
Don't look at your nose.
Winter is pretty much a straight
I
line.
want you to have a
Straight
conversation.
down?
So the same temperature all the way
Basically.
down?
It's either straight down. It's always going to be. Is this thermocline? So thermocline, it's always going to be hotter.
Do you want to
Do
go
you have something I can just doodle on?
Yeah.
Here, if we're handing
Just do it
this
along
out.
like the bottom half and we'll hand it on top.
Look like you
So
are.
if it's like the winter would be like this, it'd be like there, the mixed layer. Let's say the mixed layer is to this line, right? Maybe be like a tiny thermocline, and then just straight like that. Where the spring,
I think spring has a lot of mixing as well.
Yeah.
the summer is an easy one because it's just like a really shallow mixed layer, and then really the steepest thermocline, and then once you get past the thermocline, it's like that. Spring is.
And then spring and fall are going to be the same,
Spring
right?
is less wind, so that would be a shallower.
But it would still
I
have
think
mixing.
for simplicity's sake, spring and fall are about the same.
Yeah, which is right.
I'd say start with the first two. And,
But there is a tiny bit of a change, right?
yeah. But it's less separated. I think the fall is a deeper mix layer because it's hurricane season. Then it gets more specific. So.
It's like spring and
I
fall are
think
the
there's
ones
just
where
more
you have that huge mixing, don't you?
Yeah.
Is there more mixing in spring and fall or in winter? I thought it was in winter.
The most mixing would be in winter. Yeah.
Yeah.
And also the least heat, so it's not stratified as
Right.
much.
Oh,
Yeah,
okay.
so this is for the temperate. So I think there's like 2 mixing layers every season in spring and fall.
Maybe for simplicity's sake, I'd say spring and fall are the same.
So
I
it
think
would
there
be
might
like
be a few
little
little
bit of a change.
differences, but
So, like for spring and fall, I'm thinking it'd be cooler than the summer. So it'd start out more in the middle and then be like that.
Yeah, something in between. And it'd be a deeper mixed layer than the summer too. Deeper mixed layer.
Oh, I guess that should have been. You want to do anything?
Oh, yeah. Like that. Yeah, something like that. And then fall, I think the thermocline in fall is actually a little greater than spring. I'm probably overcomplicating because the sun accumulates more throughout all the seasons for that time. But
Wouldn't
if you
at
draw
fall you have a
closest-
pretty high mixed layer because you had the sun baking down on the surface water for like all summer, and then so it's starting to cool down, but you still have you still have a lot of less dense water mixing around at the
Yeah, it
top.
would be. There's also a lot of winds in the fall too.
Right, yeah. Yeah, so
know
that
how
would
much
increase your mixed layer, I guess.
they
It
go
would be
against each
deeper.
other.
So your thermocline would be deeper then, I guess.
Yeah.
So it'd be deeper right there.
It's pretty close to spring. If you draw it,
I don't know if he's gonna like.
Well, we get 100.
Yeah. That's good to know for the final anyway.
Yeah.
Chance
But I
something like this on it.
even the winds don't cancel out the magnitude of the thermocline. I think that would just cancel out the mixed layer effect.
Right,
The
yeah.
actual magnitude of the thermocline would be higher in fall than in spring.
Let's get our student numbers on this as well. Have you memorized the student number yet? Alright.
It's the only thing I don't memorize for test.
Alright.
Yeah, actually, that does make sense that it's wider than fall, because that's when hurricane season is too fun. And that's due to like
Fall is hurricane
the
season?
accumulation.
Yeah.
Or like late summer, I guess.
So I guess you have like
But it's all
really
that-
warm waters on the top.
Yeah,
Because
it
isn't
just
that
keeps
how?
adding
Yeah.
up.
Right.
It's like how they say thunderstorms are in the evening, because that's not like the peak of sunlight, but that's when it accumulates.
It's like, yeah, exactly. So you've had that sun baking down all day on the water, and then basically, yeah, don't fully know how it works, but
Yeah.
I'm not
It's
a
probably
Earth
way more
emergency
complicated.
major, so
Yeah.
yeah.
I'm learning about storms. I'm taking 114 right now, so
Cool.
I didn't go on it in detail.
Yeah.
Yeah, it's kind of confusing though, because you think noon is like that's like when the weight's the highest. It's almost like thinking like physics or something. It's like velocity.
Yeah, no, but I guess it's more just like you have that just it's not so much the velocity, but the accumulation of
Yeah,
energy.
the total.
Yeah.
Exactly.
That heat energy. All right. But I mean, North Pacific temperate, you don't really get hurricanes in this region.
Yeah.
Just 'cause I don't know
But
why.
it is still more wind.
Yeah, some more wind.
But yeah,
I know
wind
because like we
gets
have a spring melt and then a winter like frosting. So like I just remember like from another class there's like two mixing times every year. So, but I mean I don't remember.
I remember him saying last, like I don't know much about wind, but
Yeah.
I remember he said last class that like the fall and the winter were the big wind seasons.
Yeah.
The spring and the summer they were calm.
Fall,
so I guess-
yeah, I think spring because you have that. Well, I mean, this is for lakes, I guess, but like you have that ice breaking up, and so and spring is like it's a pretty windy time, like spring storms, right? So you get that super, and also like because you have that ice which is less dense, and then it's super cold water, and then it's melting, and then that cold water is kind of mixing in with the. Clearly, I don't understand it that well. So.
I'm totally guessing here too, but I think the thing is the temperature at the equator is constant.
Yeah.
But when it's winter, then it's colder up high, so that makes more of a gradient for like all the heat to want to travel there. That's like more chaos, more storms.
Oh yeah, no,
That's
totally.
probably a really simplified way of looking at it, but I think that kind of describes why, and then that's why the southern hemisphere would have the opposite.
Well, I mean, for this class, like simplicity is the key. So
Yeah.
yeah.
even in 314, like we learned about the winds, but even that we kind of just brushed over with more
Are you an EOS major then?
No.
Okay.
I figured I'd take 314 and 15. It's actually great.
Oh, so
I don't want to
very-
say common sense, but I studied
Yeah, it's pretty interesting some of this stuff because, like, I don't know anything about the ocean, so. Yeah. And I heard it was an easy class, so. I'm like, what the hell?
It seems like that if you said the average was like 70.
Well, I was gonna take it online, and then because I had to miss the first month of the class because of work, he's like, "We'll make it work and stuff, and you come in office hours and
Right.
just come to class because it's worth it." And it totally is. Like I'm only Monday, Wednesday, Fridays. I'm only coming here for this one class, but it's totally worth it.
Yeah, online classes are tough.
Yeah,
Like
and like
his
he makes
way
it
of
fun,
explaining
right?
stuff
So-
in words is so confusing. Can you imagine just trying to read his slides with like instruction?
It would make no sense. It'd be, I mean, online classes are shaped differently, so like they're just done differently. So you couldn't do it like this. So yeah. Where do you work out?
Lifeguarding in Richmond. Just picks up a set and then only get 3 hours, so it's like it's only Monday, Wednesday, Friday. It's one class. it's
Right.
worth it.
So you're just taking one class this semester?
Oh no! It's just my Monday, Wednesday, Friday.
Oh, yeah, okay.
Everything else I jam into Tuesday, Thursdays.
Nice.
So this is an offer for Tuesday, Thursdays.
No.
Where do you
All the foods.
Oh, okay. So
Yeah. You know what?
I used to live in Richmond.
Oh, Calgary.
Well, I was born in Richmond. Like, so,
Really?
Yeah. No, it's like my second home. Man. Yeah.
Really? Oh,
Yeah, I got family there
When
and
did you
stuff.
move to
So
Calgary?
I used to live like near Mineral, like in that area.
Okay. Cool. Yeah.
Moved to Calgary when I was 6, and then I came back. Moved to Richmond for a little while after high school.
Okay. Nice.
Yeah.
Hello?
Okay.
Right on. Good quiz.
Okay. So for how many of you was this something you could have answered in a second? Have you seen this before? Okay, so this was something that had to be discussed a little bit. Okay, even this is good. Okay, good. So it was a good in-class assignment. Okay. So there's a lot of variability in this, and it does depend a lot on where you're located. But we're dealing with a temperate environment. Why does it have to be temperate? Pardon? 4 seasons. Temperate means 4 seasons. Polar means 2 seasons. Wicked cold and not so wicked cold, right? Subtropical and tropical means 1 season, hot. Okay? So temperate is the only one where you really have 4 seasons. What happens in the winter? What's status quo in the winter? Sunny and warm and dry, right? No, what's classic January weather off our coast? Rain. And what usually comes with rain? Wind, right? How much sunlight is there? Not much. Not much for 2 reasons. What are those 2 reasons? What's day length in January? How long is day length in January? Pretty damn short. Exactly. Okay? It's what, 12 hours now or so? A little over. Have we gotten past 12 hours yet? It's better now. It feels better. We're all like less bitter about life just because there's more sunlight, right? Okay? So less actual daily light mixed with the fact that most of that light is shrouded behind clouds. So less net energy to the surface of the ocean. The average temperature of the North Pacific is about 6 degrees Celsius. What do you think the temperature is at depth? At about 1,000 meters or so? 4 degrees Celsius. So, in the winter, what's it going to look like? Anybody want to describe it?
Straight
Yeah.
on it.
Like pretty much a straight line. Yeah.
For this class, let's just say straight line. That's called isothermic. Iso meaning equal, like isosceles triangle. Thermic being temperature, right? If you did something like that, that'd be fine too, because that sort of happens as well, okay? But because there's no heating of the ocean really at all. In fact, it's losing more heat to the atmosphere than gaining from the sun. And because there's so much mixing anyway, it generally means that it's isothermic. It's the same temperature. What does that mean in terms of mixing of the ocean then? How much of the deeper water is going to come to the surface? A lot. It's going to be under surface. And what's in that deeper water? Nutrients. Exactly. So this is where all the nutrients come from. Also, what's not happening in the summer? I mean, the winter. What biological thing is not happening in the winter? Photosynthesis. Photosynthesis utilizes what for growth, other than light? Nutrients, right? So there's no photosynthesis in the winter, and you're getting a lot of mixing from deep water, which means nutrients. This is when nutrients increase in our surface waters. Okay? It's because we have this sort of isothermal. But even if we had this, that is pretty easy to break. All you need is one good windstorm, and that'll bring all that bottom water back up again, increasing nutrients. So not having an established strong thermocline means the water is not separated between the top and the bottom. It's not stratified. Okay? And that's good, because that allows nutrients to increase over the winter, which we absolutely need, which is why in like early March, the amount of nutrients in our water is really high. Really high, maximum. Okay? So that's winter. Spring comes. What happens in the spring? This past week has been perfect. What's happening in the spring?
Rain.
Rain, but also, who's put on a pair of shorts or something, or sandals, or made some effort to think that it might actually get warmer sometime in our future? Right? Okay. We've had classic spring weather this week. It's been all over the place. It was god-awful miserable, like on Friday. What day was it where it actually fell? And this morning, biking in, I biked less than a kilometer, almost got killed, and was soaking wet all at the same time, right? That's pretty much
Wait, you bike from Point Robert?
No, from the parking lot. Shows you what kind of biker I am. I forgot that I hadn't touched my brakes for a while, and so I hit the brakes and just went right through the intersection. Pissed off the guy in BMW. Okay, so spring is a mixture, but you are getting more heat from the sun, and you're getting slightly less storms. So what's going to happen is sunlight is going to start warming it up, making the surface of the water a little less dense, right? But it's still being mixed a bit. So what's going to happen is you're going to get the beginning of a mixed layer. It's just going to start peeking out, okay? And it's going to disappear. You get one big storm, which happens. It's going to disappear, and then a day or so later, it's going to reappear, right? We're in a transition phase, right? And what's going to happen is this mixed layer is going to get warmer and shallower as the spring progresses, to the point where the thermocline is so drastic, mixing between the surface water and bottom water is not going to really work. It's going to be highly stratified, okay? Which means you're no longer going to get nutrients coming up from the bottom. But why is that good, though? Why now did phytoplankton grow? This is all getting to critical depth. It's getting close to the surface. The mixed layer is going from a couple hundred meters to 150 meters to like 80 meters. Okay? So the phytoplankton that's being mixed from the surface to the bottom of the mixed layer is going from down to 200 meters, to down to 150 meters, to down to 100 meters, to eventually where it's going to be shallow enough, and remember, nutrients are high at this point, it's going to be shallow enough to get a bloom, and that's why we get a spring bloom. So at some point, critical depth is going to equal mixed layer depth, and boom, you're going to have a huge bloom. Okay? And as spring progresses, the mixed layer is going to get shallower and shallower and more defined. Okay? So which means in the summer, what's storms like in the summer? Almost non-existent, right? What's temperature like in the summer? Hot. What's day length around here? 14 hours, is that what it is? Something like that? Something crazy? 14, 15 hours? You go up to, almost up to Alaska in the North Pacific, and the sun sets at 11:30. Okay? It's insane, right? It sets at 11:30 and rises like just before 4 in the morning. You get a lot of work done. You go crazy, but you get a lot of work done, right? Okay? So summer will have a lot of heat, but not a lot of mixing. So that means you'll have a really well-developed and very shallow thermocline. Okay? And this thermocline means the surface water is highly stratified. Very different from the water underneath it. So what does that mean in terms of nutrient exchange? Are a lot of nutrients going to be mixing from the deep? No. It's like having a glass ceiling or a glass floor. Nothing is essentially mixing between the two because there's such a difference. It is like oil floating on top of water. It will not mix. You leave it there for a couple weeks, come back, and no mixing has occurred. Okay? What happens in the fall? What happens in the fall? Reverse of spring, I guess would be the way to say it. Sunlight, what's maximum sunlight or daylight? What time of year? June 21st, right? So, first day of summer. You know what's interesting? I'm curious if you guys can explain why. The depth of the mix layer gets shallower after June 21st until about August around here. Gets shallower. Why? Even though day length is beginning to decrease, why is the depth of the mix layer getting shallower? Shallows up to about August.
So just because heat in is, like the heat in is going to be greater than heat out. Like it's still storing heat in.
And what's not happening? What's also not happening?
Storms?
Storms are not happening. It's getting calmer. The calmest time of the year around here in terms of wind speeds is July and August, right? So even though day length in June is long, there's still enough wind to do a little bit of mixing, okay? So what's happening in July and August is it shallows up mainly because winds pretty much die down, I wouldn't say to zero, but to the lowest amount it does during the year. So even though day length, sun input decreases a little bit, right? Mixed with the fact that because you have such a shallow mix layer, the sun has more of an effect on the surface because it's only heating the surface of the ocean. Technically speaking, the wind and the sun only influence the top layer molecules in the ocean, right? So for wind, it's friction. Wind blows across the top molecules of water. Those molecules move. That makes the molecules underneath that move, which makes the molecules underneath that move, and that's how you get mixing. Sunlight, same thing. The sun only shines on the top layer molecules of water in the ocean, warms them up, they get kinetic energy, they start moving. That starts transferring the kinetic energy to the molecules below that, and so on and so forth as it gets deeper. But because it's so shallow, in July and August, it's still warming up quite a bit, and so it gets really shallow. But then what happens in about October? Sort of depends on whether we have a really nice, sometimes you get, the best time of the year is September, I think, in Vancouver, in the Pacific Northwest. Most colleges, except for this insane one, have September off for that reason. I don't know if you noticed that. UW, University of Oregon, Oregon State, they all have September off. We're the only idiots who still have to be in school. Because it's so nice out, right? Okay? But what happens in the fall? So we hit October. Storms increase, and sunlight is decreasing. So what happens is your summer mix layer starts getting a lot of storm input. Let's put storm this way, right? So you get a lot more mixing, which means the energy is making it go deeper and deeper. Okay? So what will happen is the mixed layer will get deeper and less defined, less stratified, as we get more towards winter. And then eventually it's going to get to the point where it becomes isothermic, or close to it. The key to remember is if a thermocline gets hotter, it's going to expand and get shallower. Okay? So if the surface of the ocean gets hotter, it's going to get shallower, but become more stratified. If mixing is occurring in stronger amounts, the ocean thermocline will start getting colder, but deeper. Okay? An ocean is much more likely to mix in this scenario than the highly stratified. Highly stratified, minimum stratified. Not stratified at all. Okay? Here, nutrients can come up from below. Here, nutrients are more likely to come up from below. Here, nutrients are not going to come up from below at all unless there's alcohol. How do we feel about that? Something to understand, this is like as deep into physics as I want you to go. Temperature is just the measurement of the kinetic energy of the molecule. It's a measurement of energy. Heat doesn't really exist. It's just energy. So when you take a temperature reading of something, you're measuring the average movement of those molecules. Okay? So if you have a Starbucks cup, and you take all the energy in this Starbucks cup, and you put it in a bathtub, and you fill the bathtub full of water, and the same amount of energy exists in the Starbucks cup as the bathtub, what's going to be the difference in temperature between the two?
Huge.
Well, the Starbucks will clearly be below a temperature that you can sue them for, right? Unless it's like, you know, I don't know, an iced coffee or something like that. But what's going to be colder or warmer or the same? Yeah. Exactly. So if you take the same amount of energy, put it into a bathtub, because the bathtub is bigger, energy per molecule is less. And that's all colder means. Okay? So when you mix deeper, that's why temperature decreases. Because the average amount of molecules influenced by that surface temperature increases, therefore the net temperature of the surface mix layer decreases. Does that sort of make sense? It's as much physics as I want to go. It's a little bit more than I want to go. Does anybody have any questions about that? Kind of need to understand that if we're going to progress forward. If you're not sure, please come talk to me, okay? And I'd be more than happy to sort of clarify it. We're going to go through it over the next couple slides anyway, and we're going to get back to where we started. So we're basically getting to the point where we ended on Monday today. So I don't know what that means. It's good for teaching you guys. Okay? Please turn in your papers so before you leave. Okay, don't leave without it. Okay, so I'm not going to go into this. This essentially summarizes exactly what we just discussed. Okay, talks about wind, no sunlight. There's no spring here, but summer, more sunlight, less wind, and then in the autumn, the wind decreases and less sunlight. Okay. So what that means is that we have these established mix layers where temperature, salinity, and water density will all be uniform in this parcel of surface water. In addition to that, pressure will be the same. Well, pressure varies a little bit, but don't worry about that. Nutrients will be the same, and plankton numbers will be the same, no matter where I take a water sample. If the mix layer is 100 meters, if I give you a water sample from 99 meters, and I give you a water sample from 5 meters, they should look exactly the same. You should not be able to tell the difference of either. And once again, it's the washing machine thing, right? Assume the mix layer is uniformly mixed throughout. Okay, right? So surface of the ocean, highlight, because it's exposed to the sun. Warmer temperatures, generally. More oxygen. Why more oxygen at the surface of the ocean? There's two reasons. There's a physical reason and there's a biological reason. What's the physical reason? Where does most oxygen come from? Pardon? From the atmosphere. Diffusion into the surface of the ocean. This is why in your fish tank, most of your oxygen, your fish tank, is not coming from your bubbler. It's coming from diffusion from the surface. Okay? Why else is oxygen high at the surface? Photosynthesis. Exactly. So photosynthesis is adding it and making more oxygen at the surface of the ocean than there should be based on chemistry alone. Super saturated with oxygen. Okay, so high oxygen at the surface, plenty of nutrients. The biggest change of temperature, salinity, and density is all going to occur in the exact same area of the ocean. Roughly the bottom of the mixed layer to about 1,000 meters. Depends on how deep the mixed layer is. Generally the mixed layer, if there is one, won't be any deeper than about 200 meters. Okay? And at about 1,000 meters, there's absolutely no more influence of the sun, and there's no more influence of wind. Therefore, you're getting to what's called the constant ocean. Temperature is the same. Salinity is the same. Doesn't matter if you're in the Pacific or the Atlantic, the North Pacific, the Southern Ocean, it's all roughly the same. It's also pitch dark at that point. Once you get to 1,000 meters, you're now in the abyssal pelagic and it's pitch dark. Okay? But that will also have uniform light, uniform temperature. It'll be high in oxygen because it's cold. And if you take 314, we'll explain why in more detail. It'll be high in density because denser water is always deeper because it's heavier, right? And nutrients will be high because they're not being utilized by photosynthesis. Are we clear with this now? Do we understand what a mixed layer is? The mixed layer is crucial to understanding primary productivity, biomass, and all this other stuff. Yeah?
Does this layer vary so much that it's harder for animals to adapt to that area?
Well, actually, it's a great question. In terms of, this is why there's no like land plants in the ocean. It's because, yes, only specific types of organisms, technically ones that can overturn themselves very quickly, like phytoplankton, single-celled organisms, are the only ones that can adapt to that kind of variable light regime. And the light regime can change on an hourly basis or a daily basis, as opposed to here, where it's on a seasonal basis. So yes, but if you think about it, there's two ways of looking at it. One is it keeps other organisms out, but it also means that if you can successfully compete in that circumstance, like a diatom, your competition with other organisms is minimal. Okay? It's a very specialized organism that can deal with that. That's why phytoplankton are different. Okay? You sort of get that? It's a really nice point, actually. Okay. So now we get back to this thing again. Okay? Compensation depth is the depth in which the whole mixed layer, the amount of light the whole mixed layer essentially needs to be exposed to for the phytoplankton population to be able to grow. Okay? So if the mixed layer is deeper than the critical depth, there'll be no growth. In fact, you might lose biomass because there'll be more respiration than photosynthesis. If the mixed layer is less than the critical depth, and as long as there's plenty of nutrients, you'll have a bloom. Because of the issue with this, I decided I would actually go one step further and make another figure. So this might help a little bit. This is a simplified version of what's going on, but this may help. So here we have winter, spring, summer, fall, winter. Okay? Mixed layer depth, like we were showing here. Mixed layer depth is very deep in the winter, shallower in the spring, very shallow in the summer, and then deepening up in the fall. Okay, can we see that now? Do we agree with that? Sunlight per day is increasing from December until June 21st. Sunlight per day is increasing from January to June 21st. Okay, so that means the critical depth, the amount of sunlight into the ocean, is increasing until June 21st. Which means critical depth, as we start going towards June, will get deeper and deeper and deeper. Till finally you'll get to an inflection point where the mixed layer meets the critical depth. This is an oversimplification because there's storms, and one day it may be deeper, then one day it may be shallower, then the next day it may be deeper again. In spring, you get these sort of little blooms that begin and then end because you get a storm afterwards. It takes a little bit while for it to kick in, but it will. Okay? So here, they're light limited. Doesn't matter if there's plenty of nutrients. There are because it's temperate, but it doesn't matter if there's plenty of nutrients. They can't grow. All you need to be is limited by one thing as phytoplankton, you can't grow. Light or one particular nutrient. Okay? So no growth whatsoever. It doesn't matter what you do to them, they won't grow. As the mixed layer gets shallower than the critical depth, mixed layer less than the critical depth. Okay, same thing here too. When you have the mixed layer greater than critical depth, no bloom, light limited. As long as the critical depth is deeper than the mixed layer depth, they're no longer light limited. And as long as you have plenty of nutrients, they can grow. So if I superimpose a phytoplankton biomass figure on this, okay, these are all lined up with the right times, right? This is January, February, March. This is April. Right here, where the critical depth meets the mixed layer depth is right here. Should be actually, I should move this over. It should be right here, essentially. I will move that over and polish it again. Should be right about here, okay? There's plenty of nutrients because they built up all winter. There's no photosynthesis and lots of deep water mixing. So boom, it'll take off. And it will take off dramatically. It will not be there one day, and it'll be, a week later, it'll be like, you know, brownish green nastiness. Okay? And it can often be fueled by just a single cell. Just seeded by one diatom cell. That's all you need for exponential growth, right? So you'll have a big bloom. What's happening here? Why does it stop even though it's no longer light, it's not light limited? Why does it start going down?
Can run out of nutrient?
Pardon? Runs out of nutrients. What nutrients does it usually run out of? What nutrient is it most likely to run out of in the ocean? Nitrate, yeah, nitrogen. Nitrate, ammonium, something like that. Sometimes it's iron, sometimes it's phosphate, usually it's nitrogen, nitrate, okay? So when you look at the actual nutrients, in this case nitrate, you'll see the same thing. Maximum in the winter, because there's no photosynthesis and lots of mixing. Extreme drawdown, where it will reach 0 at the end of the biomass peak, right? They are now nutrient limited to this whole portion. What's going on here? Why do you see a nice little blip there? Why do you see a slight increase of biomass right around the fall cutoff? Yeah. Mixed layers get deeper. Why? It's cooling down, and what else is happening? More fall is occurring, so what kind of weather do we get? We get more wind, more mixing. But it's still not so deep that the mixed layer is greater than critical depth. They're still not light limited. So you'll have these little storms that kick in September or late August and September and October, which mix enough water to bring some nutrients up, but still establishes a pretty good mixed layer. And that'll be enough to get a little teeny phytoplankton bloom in the fall. And then what happens here? It becomes definitively light limited. Okay? How do we feel about that now? Is that a little bit better than the nightmare that was last week or last Monday? Okay, that's the nutrient limited zone. So if light is no longer the limiting factor, phytoplankton will grow until the nutrients are exhausted. What are the major nutrients that we have to worry about?
Nitrogen, phosphorus.
Nitrogen, mostly nitrate. Phosphorus, phosphate.
Iron.
Iron as a micronutrient, definitely. What do we also have to worry about that's a little different than trees? What other nutrient? You can eat grasses even too. Silicate, exactly, diatoms. And it's so weird because it's one group of organisms that is a small group. It's not a very diverse group compared to other groups. But because it's so dominant in terms of its primary productivity, its silica utilization is extremely important. So we have to pay attention to nitrate, silicate, phosphate, and then to some degree the micronutrients like iron and those kinds of things. Okay? So nitrate's commonly the limiting nutrient. It's the second most needed nutrient after carbon. Carbon is generally not limiting in the ocean. Turns out it actually is, but that's not for this course, right? Nitrogen is essentially required for things like proteins, DNA, and essential part of photosynthesis and those kinds of things. Okay, and that's why you end up getting a profile. What's the depth of the mixed layer here, by the way? Can you tell the depth of the mixed layer from this graph?
60? Or is it
It's
120?
20.
20 meters, exactly.
Oh, okay.
Even temperature, even density, even salinity, even nutrients, and even phytoplankton biomass. Okay? So this is telling you that the surface of the ocean at this location is nitrate limited, because nitrate's at 0. So you know immediately you're dealing with a spring or summer in an area where there's plenty of sunlight, because nitrate is 0. Okay? Okay, continue on Friday. Turn in your paper before you leave.
Oh, I was just like, you're writing everything down.
I did. I don't even read it after. It's just so I don't.
Well, it helps when you're writing.
So I don't zone out in class.
Yeah.
Especially when I got like blind class.
No, yeah, that definitely happens, boys. I know,
He isn't too bad.
yeah. No, I find myself sometimes going on these, like,
I even actually I tried to tape a lecture from a class prior.
yeah.
I had a little problem. You'll notice right away.
Guys will come soon.
This is
Okay? Yeah. Yes.
the frantic typing is
Yeah.
overpowering. I can barely hear it.
Oh, that's funny.
I'll have to figure out how to solve that problem.